Okay, so yeah, we've got two techniques for solving quadratic equations. We can solve by factoring. Solving by factoring is a good idea if factoring is easy to do. If it's not easy to do, we'll move on to a different technique. We have the technique of isolating x by square root property. If we have a quadratic equation where we can point to a single x, then we do that. We just use inverse operations and isolate the x. Okay, today we're going to come up with a different technique that is going to be which gives us another option if we are unable to factor a trinomial. If we start off with a quadratic equation where we cannot point to a single variable, but we can't factor it either, then we could do this, okay? So let's start off with a little warm up here. So let's just factor a couple things. Let's take that top green one. What's that factor into? Jaden, how's that factor? There you go, x plus 4, x plus 3. No big deal, right? Okay. How about the blue one? What about the blue one here? What do you think? Plus 4 plus 4. Aha, okay. How would we write that? X plus 4 quantity squared. Okay. So let's solve the blue equation then. What could we do? How would we solve that equation? Subtract 64. We're going to set it equal to 0, right? Okay, we're going to put it in standard form. We can't isolate x there, can we? Right? So we have to solve by factoring. It's the only method we know at this point. Set equal to 0, factor, apply the zero product property. So if we subtract 64 from both sides, what are we going to get? Minus 48? Okay, now what? Okay, there you go. Positive 12, negative 4. Good. So we could factor this, couldn't we? So what's one solution then? Negative 12. Okay, by the zero product property, we know that either x equals negative 12 or x equals positive 4. Okay, good. And then if we wanted to solve this one, what would we do? Subtract 30. Okay, that's going to give us x squared plus 7x, minus 18 equals 0. Can we find magic numbers? Okay, 9 and negative 2. And so our two solutions are negative 9 or, okay. All right, so yeah, could we solve that first one a little different way? Now look what's on the left side. Look what's on the left side. You guys factored that a little bit ago. That factored into x plus 4 quantity squared, didn't it? Right? Okay. And the reason it did that is because what we started off here with, this was called a perfect square trinomial, right? Which factored into a same magic numbers twice, is what we always said, right? If we have a perfect square trinomial, we get the same magic numbers twice. So I'm always going to get a factor squared. Okay, let's take advantage of that. Anybody want to take a stab at another method for doing this maybe? Say it again. Okay, so we could factor, the left side is a perfect square trinomial, right? So we could factor the left side into x plus 4 times x plus 4. My magic numbers are 4 and 4. So x plus 4 squared equals 64. Aha. Now that looks different, right? All of a sudden we changed to a situation where we don't have to, yeah, we can point to a single x, right? We don't have to solve by factoring anymore. Now we can solve by isolating. I can point to a single x. So what would my first step be to isolating x? Square root. Okay, so if we square root both sides, I'm going to get x plus 4 equals plus or minus, excellent, plus or minus 8. Okay, and then last step. Okay, where do I put the negative 4? In front. Okay, so we're going to go there, aren't we? So we end up with x equals negative 4 plus or minus 8. So what are my two solutions then? X equals, if I take the plus, what do I get?
12. Sorry, 4.
4, okay.
And then the other one is 12.
Or if I take the minus, x equals negative 12. Okay, those look familiar, don't they?
Yeah, they do.
Right? Same solutions we got up there. Okay, can we do the same thing here?
No, it's not a perfect square trinomial.
Yeah, we're stuck, right? It's not a perfect square trinomial. So there actually is a way we could go about this. Oops, hang on one sec here. Hang on. Okay, so yeah, we can't, I mean, we can, but it's going to be a little bit tougher to do. And we can't do it real conveniently like this because this is not a perfect square trinomial. If we tried to do something similar to that, that doesn't do me any good, does it? I've got two x's, right? So sometimes people want to say things like, okay, x plus 4 equals 30 or x plus 3 equals 30, but that's not true, right? That doesn't have to be true at all. I don't have to multiply by 30 to get 30, right? Does that make sense? Or if I set those equal to 0, well, then it wouldn't work, right? Because if either factor is 0, I'm going to get 0, not 30. So this is not going to work, right? Right. That technique doesn't work. This one, we would have to do, at this point, we'd have to do this one the way we did the first time. We'd have to factor, solve by factoring. Set it equal to 0, factor it, apply the zero product property. We had a little bit of a choice, though, with the blue one because we happen to have a perfect square trinomial, okay? All right, so remember these pictures? A little bit. Let's just take another glance at these, kind of remind ourselves how completing the square works conceptually. If I've got two areas, one of them corresponding to two rectangles, one of them is a square, an x by x square, and one of them is a b by x rectangle, then the sum of the areas would be x squared plus bx, right? Okay, well, we want, by completing the square, all we're going to do is we're going to cut this rectangle up into two congruent smaller rectangles, right? Two skinny rectangles. We're going to flip one of those around horizontally and join them onto the square. And we end up with something that looks almost like a bigger square, right? And what would the dimensions be? Instead of being x by x, if I cut this thing down the middle in half, it would have a width of b halves, right? B over 2. So the total width then, when I combine all those pieces together, the new width would be x plus b over 2, and the height, would, instead of being x, would be x plus b over 2. But it's not quite a square. We've got that one little divot down at the bottom. In order to complete the square, to fill in that little divot, we would have to add that little tiny square at the bottom. And what would the dimensions be? It'd have to be b over 2 wide and b over 2 tall, right? So to complete the square, we would add to the first two terms, x squared plus bx, we would add b over 2 quantity squared, half of b squared, right? Remember, that's how we complete the square. And here's a way to think about it, right? Okay, so we end up with x squared plus bx to complete the square. We're going to write it as x plus b over 2 quantity squared if we add b over 2 squared, right? So in other words, this big square, this square right here, this one, that big square would have dimensions x plus b over 2 quantity squared. What's that equal to? Well, it's equal to x squared plus b times x plus that little additional piece we had to add, right? There's my original square plus my original rectangle plus that little bit extra we had to add, right? Okay. Okay, so that gives us this concept of completing the square. Okay, so let's go back and let's practice this a little bit. So say we start off with an expression like this, x squared minus 1/5 x. In order to turn that into a perfect square trinomial, what term would I have to add to that to make it a perfect square trinomial? That looks like x squared plus bx, doesn't it? So what would I have to add? What's my value of b here? Negative 1/5, right? Okay, so if b is equal to, I've got to add the term, I've got to add half of b squared, right? Okay, what's half of b? Negative 1/10, right? So I would have to add then the term negative 1/10 squared, which is what? 1/100th. Right? So that's what I'd have to add to create a perfect square trinomial. Okay, write the trinomial. Well, wouldn't it just look like that? Right? Okay, we're adding 1/100th to my original two terms to create a perfect square trinomial. And what's that going to factor into? What magic numbers would multiply to positive 1/100th and add to negative 1/5? What would it be? Okay, you're probably trying to think, man, that's tough with all those fractions, but it's not at all because it always has the same pattern. It's always going to be x plus half of b every time, quantity squared, right? So we're always going to get the quantity x plus half of b. Well, half of b is negative 1/10, right? Whatever this number was this number right here that we squared, whatever that number was, that's always the number that gets combined with x inside the factor. It's always the magic number that shows up twice, okay? So you don't even really have to use your head there. You don't have to think about this at all. You know that in order to get that positive 1/100th, you squared negative 1/10. So that's the number you attach to x. Okay? All right, let's try a couple examples. So here's the process then. If you want to break this down into some steps for solving by completing the square, this is a comprehensive list of all the steps. You don't always even need all these steps, but you'd never need more than this. This is it. So you're always going to, first of all, start off with your equation. You're going to separate it into the x squared term and the x term and push the number to the other side of the equation every time. Then you have to get this into the form. You have to make it look like, x squared plus bx equals some other stuff on the other side, right? So to do that, we've got to divide both sides by a, if there's an a other than 1, okay? Divide both sides by a so it looks like this form. X squared plus bx equals some number, okay? Now we complete the square, right? By taking half of b, we square it, and we add it to both sides. Then we factor the perfect square trinomial, and at that point, we just solve by isolating, okay? Let's try it. How about one like that? This is just number 3 on your notes. Okay, let's solve by completing the square. Okay, what's first step? Good, I got to subtract the 56 to the other side, right? So I just get the x squared term and the x term by themselves on the working side, where we're gonna be completing the square. So first step would look like x squared minus 18x equals negative 56. Okay, next step, divide both sides by a. Do we even have to do that? No, a is equal to 1, so we can just skip that one this time. We don't even need to do it. Okay, complete the square by taking half of b and squaring it and adding it to both sides. What's that going to be? Say it again. 81. How'd you get that? Negative 9 squared. Here's how I like to show that. Now, we can combine these into one step. Notice I left a space there. When I push the number to the other side, why did I leave a space there? Because I have to add something there, don't I? I have to add something to both sides. Okay, so what I'm going to add to both sides, let's take this step and we'll make this step green. Okay, and really we're just going to do it up here. Okay, I'm going to add to both sides half of b, which was negative 9 squared, right? On the other side, let's actually just turn that into a single number. Let's simplify that. So that's plus 81. Okay, why did I leave it as a negative 9 squared on the left side? Because the next step is factor, right? There you go, right? Because when I factor it, look what's going to happen. When I factor this thing, I know that we're going to get x plus something squared. What's the something? Yeah, look, it's the negative 9, right? Right? Whatever number you're squaring there is the number that's going to get combined with x. Okay, so right? And then on the other side, that's just equal to whatever negative 56 plus 81 is. Isn't that just 25? Now it's easy, right? Now this is a problem you guys have been doing for a long time. Now we can point to a single x, so we just isolate the x by, by square rooting and then adding 9, right? Okay, so they break this down into 2 separate steps. I think that's kind of silly, personally. I mean, we're just solving at this point. I would say steps 5 and 6, we could even just take both of those combined. Like just combine those into one big step called step 5, which is solve for x by isolating. Okay? Because we're really done completing the square right there. Now we solve by isolating. Okay? Make sense? Okay? And so I guess we should do that probably. So if I do that, I'm going to get x minus 9 equals what? Plus or minus 5. So x equals 9 plus or minus 5. So I'm getting both my answers there, right? Okay, let's try another one. How about that one? What am I doing? Oh, board work? Yeah, that's fine. Go to the board. Yeah.
You have to write x squared minus 10x plus 15. Oh.
What's that? How come? Oh, yeah. Yeah, why don't you guys want to work together there? Here, I'll get you slates. Forgot about that, yeah. How's your leg doing? No pain anymore?
No, I'm still on painkillers though. So.
Yeah. Done? Oh my goodness, that was fast.
That's because we're so smart. We're
I guess.
geniuses. Also, sir must have had caffeine or something. Actually,
Evidently. Yeah,
we're
that's
actually
right. That's
weaning
right.
off of Cartier before we had to go full on cold turkey. So I actually didn't have any Cartier. I do this in the pool.
Yeah.
Because how does this swim do?
I don't know why we did two separate. Well, I guess it is 9. Square.
Okay, but you're doing it right, but what's 25 minus 14? It's not 9. You just did. I just thought the same thing. What is it? 25 minus 14? That's 11, right? Not 9. But you're on the right track. Keep going. Yes. Good.
I did the same thing yesterday. That's fine. I did the same thing. So it's negative. I also know it's arson.
Well, that's kind of not a happy one there. Okay. There you go. Good. Plus or minus.
I think I win. You like my French pig? You like my French pig? I don't know how to do the thumb out.
Yeah. Square root of 11, though. Yeah. Okay, good. Grab a seat. That's good. That's good.
I can't do the thumb out. I can do the thumb in. Oh wait, do we have to raise it?
Okay. No, stay there. Actually, try that one.
Oh, yay! Okay, 2x squared minus 16x. Okay, and then so then x squared equals negative 30.
Yeah, that it needs some work. Needs a little work.
X squared minus 8x. And then you gotta add 16. Yeah.
I watched the video, bro. I watched it on YouTube.
Wait. Oh. Oh yeah.
Yeah. Think about. There you go. Good. All right, now you got it. Okay.
Oh boy.
Okay. So, but I want numbers for those. I mean, you got it, but what would you get out of that? Don't leave it like that. I know I did on that last one. I was being lazy, but Yes.
That's pretty good. I did that on
Okay.
Screw it or run if you want. Oh.
Yeah.
Oh, yeah.
So what are your answers then? 5 and 3. Positive 5 and positive 3. There you go. Good. Okay. Man. What's that?
She's judging your diet. Do you like Diet Coke?
Oh, we had our yesterday for our. I had to stay awake. We had our grading day. Oh no, I don't like it very much. I don't drink very much of that. Okay. Okay. Okay, try that one. Yeah, so that's 5 and 3, right? Yeah. Right? X4 plus or minus 1 is just 5 or 3.
Oh, we gotta do some fractions here? Decimals?
Still refuse to make a transfer. I don't know what to do my as soon as I was done at this. What's your channel name called?
Plus 11x minus 5.5.
Is that what you actually did?
Plus or minus the square root of
That'd be
so oh yeah, we're supposed to do fractions.
Yeah?
Oh well, mine's a decimal. What's 7 times 4? 28. 28 plus 21.
Wait, we don't need to calculate.
No calculators. You gotta use mental math. What'd you get?
What's the limit of
Okay, but you got to simplify the square root.
Oh, you got. Oh, wait, there's a tent in the basement.
11 squared is 121. 2 or 4, right?
11 squared?
Yeah.
121.
Yeah.
Yeah.
121.
121 divided by 4 is 121 fourths. Okay, now what about that second part? Okay, so right, so you added the 7 to the other side. Okay, now you're adding those, right? Is what you're doing. Agreed? You're adding those though, right? There you go. Okay. So you got to add those up. You got to get a common denominator and add those up. Yeah.
Really?
Mm-hmm.
Thanks for the help, Sarah. I did it all.
I'm going.
Ooh, okay. Okay, I think I see a couple, maybe, boy, I see one completely right. Okay, let's, how about if everyone just drop what you're doing? Let's go through this one together real quick. So everybody focus up here. Here we go. Focus up here. Not, it's close. Very close. Okay, so everybody, what's my first step? I got to add the 7 to the other side, right?
Yeah, you do.
Okay, I'm waiting. I want everybody's no writing. Everybody's looking up here, please. Okay, so I left space. Now, what am I adding to both sides? Okay, I'm adding 11 halves squared, right? Half of b squared. So I'm adding, which is 121 fourths, right? Okay. Okay, the left side is actually pretty easy. What does the left side factor into? Right? Okay, everybody, right? We good with that? Okay, I don't feel like I got 100% focus up here. There we go. Right, so we know, and there's a connection there, right? We know that whatever that number is that's being squared, that's what's getting joined to x inside that's my magic number that shows up twice. So I'm getting a squared factor. Okay, on the other side, I would just have to multiply this one by 4 over 4, right? To get a common denominator. And so what's that going to give me then? I'm going to get 28 fourths plus 121 fourths is, is 149 fourths. Okay, so we're done completing the square. Now what? We just isolate x.
Yeah.
So what do I do?
Square root.
Square root both sides?
It's like Disney Channel, but
So I'm going to get plus or minus, right?
yeah.
Plus or minus the square root. Square root of 149 over the square root of 4. What's the square root of 4? 2. Okay, so plus or minus square root of 149 over 2. Last step. Okay, I'm going to subtract 11 halves from both sides, and it goes there, right? And so my final answer just looks like 11 halves plus or minus the square root of 149 halves. There's both my answers. Okay, good? All right, you up for a challenge? How much time we got? 1 minute. 1 minute tomorrow.